Hi, welcome back to Two Think Minimum. Today is Wednesday, February 23rd, 2022. I'm Sarah Olam, a senior fellow at the Technology Policy Institute. I'm here with TPI President and Senior Fellow Scott Wallsten and TPI Research Associate and Software Engineer Nathaniel Lovin. Today, we're delighted to talk about the technology needed to build and use a broadband map. States are soon going to have to make broadband plans, and funds are going to be spent from the IIJA or the Bipartisan Infrastructure Law soon. And each of the states are going to be using broadband maps and data. Well, luckily, Technology Policy Institute here, we've been building a broadband map that has functionality to serve those purposes. And we have our team here to talk about it. Scott, can you tell us a little bit about why we're doing this project?
Sure, Sarah. Yes, so as you know, we've done lots and lots of empirical work on broadband. And so for the last decade plus, every time we wanted to do something, we would download one data set from the FCC or the census and then work with it to merge it with another data set, because real insights come from combining data sets, usually not just a single data set by itself. And the downloading of the raw data and merging it to whatever specific other data set we needed, it would take a long time. It was complicated. And it seemed like we were doing it over and over and over again, which seemed kind of wasteful. At the same time, there was this general talk about there not being a broadband map. And that sort of seemed silly to us because there's lots of broadband data. It was possible to make a map. And of course, if some maps did exist. But we decided, this problem had a solution and we would provide it. And so we built this platform that allows us to take any data set really that exists and merge it with any other data set and do lots of things to it. You'll talk about later how we built it and the front end we built for it and how much more we can do on the back end, how it's allowed us to answer policy questions and just be incredibly, incredibly useful. And I think also highlights, it's not just the map, it's how you use the map. And like you said earlier, when we were just talking, that this is really, it's just a tool in our toolkit. Having a map isn't enough. You have to be able to work with it and use it for analysis and answer questions.
Nathaniel, could you tell us a little bit about why our map and how our map is different from other maps? How many data sets have you personally loaded into that map?
Let me actually count this so that we have an actual number. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's at least 9 different data sources. Depends on how you divide them up, obviously. We have main difference between our map and pre-existing maps is the depth of it. We have substantially more data sets aggregated together than most of the other maps out there. We also have real commitment to keeping it updated and not letting it stagnate, and it is set up so that it can be updated near instantly when new data sets come out. We have put a lot of work into not just displaying the data, but also allowing analysis of the data via graphs and plots and regressions, which I think nobody else has been really doing to the extent that we've achieved it. So the first and main part of it is I've built several tools that make it very easy for us to combine the data sets at a specific level into like bigger geographic areas so that we can have analysis not just at the raw level of the data, but at aggregated levels. I'm using GIS and stuff to analyze what census blocks are in each zip code so that I can assess what level of service is theoretically available, the FCC Form 477 in a given zip code. So I do that for, 23, 24 geographic areas in total. And so...
You mean geographic types, right?
Yeah, geographic types. That's the biggest thing. The second part is just we're using cloud technology like Google BigQuery to allow that computation of those combinations to go extremely rapidly. If I was just running this strictly on my laptop, it would take days to do all the calculations, but I can put it into BigQuery and it will do the calculations in 5-10 minutes max, usually less than that. But, I can run a decade's worth of combinations in, an hour for all the geographic areas if I need to.
And something like that, of course, is very useful potentially to states who have to come up with their own broadband plans and may each have different preferences on how they want to look at broadband within the state. Some states might be interested in a high level at the counties. Others might want to know about congressional districts or even state legislative districts or school districts. Any of that's possible. And I hesitate to use the word simple because it's simple for me, and Nathaniel knows all of the complexities of the back end, but we can do it all without taking too much time.
Yeah, and that brings us to the point of what we do is we look at all the broadband maps that are out there, and we also are looking at all the state broadband maps. Every state seems to have a broadband office now, and they're staffing up, they're getting ready to spend billions of dollars of infrastructure funds. And we want to be like a resource for people who are building maps and using the maps. And I just want to bring it back to Nathaniel a little bit. Like, what have you seen in the maps that are out there? Like, we're one of 50 maps, broadband maps that are out there. What do you like about other maps? What do you like about our map? What could be more helpful for policymakers?
The thing that I really like about our map is that it puts the data into context better than a lot of the other maps out there because of the regressions and the time series data. There are features on other maps that are really nice for mapping. Georgia lets you slide between 477 data and their own data to show the difference. Broadband now has a pretty good collection of pricing data that they've assembled. There's a lot of interesting data sets out there, but just showing a map of data is interesting, but it doesn't help you make decisions, really. It just shows you what's happening, and you need more additional features to be able to actually get useful action from the map.
Nathaniel, what do you think has been the biggest challenge in making this work?
So the biggest challenge was just dealing with all the weird little inconsistencies of the data. Like the Census Bureau has 7 different ways that they have null values in the data or, no value or so. I spent a couple of months trying to figure out how to fix the geography so that I could analyze them for the USAC data. And a lot of it is stuff that is having to deal with the fact that the data sets are just a lot bigger than things are built for. So, you could fix the study areas if they were smaller with ArcGIS, but you couldn't, but they were too big to run it was too big of a file to load fully on my computer to fix. So I needed to do it in BigQuery, but BigQuery wasn't supporting this at the time. So until they fixed it, I wasn't able to get it to work. Similarly, I've decided to change on this, but for a while, we were trying to figure out how to get the mobile Form 477 data into the system using the shapefiles. And they were too big to fit into the Google big data platform. You could not fit the row size of BigQuery could not fit the size of the row needed for that data set. And so we had to do a bunch of stuff to break them up, which took 2 weeks last summer, I think, to run on iMac that one of our interns was using. And then once we got into BigQuery, there was a bunch of issues with actually processing the data and figure out an algorithm that would be cost effective for doing that. So we eventually decided to just use the pre-calculated actual area stuff from the FCC.
Right. So, for people who work with a lot of data, a lot of that might sound kind of familiar to them. But, for people who deal more with just the broadband policy part of it and not in the detailed data, these small issues can make a big difference. I mean, the way you deal with zeros and missing values can hugely affect your results. If you get it wrong, if you put zeros in where a value is actually missing, you mess up all your results. And if you don't know that 999 means no data and you interpret it as 999, again, everything's messed up. And they're, like you said, they're all different. Census had 7, you said, different ways of showing no data or something like that. Yeah, I mean, this is just all nature of working with data. But for each one of these data sets, we have to make sure we know what they're saying and that they're done, when we have them in their in a consistent fashion.
So could you tell us a little bit more, like, why would we need to run regressions on the map? What makes the computation part important for a broadband map? Why can't it display a map?
I mean, in terms of why we need to be able to run regressions, of course, is you want to look for relationships between variables. And regressions, in our opinion, are probably the best way to do that. And it is another way of making use of multiple data sets coming together. And also, I think to go back to Nathaniel, making that possible is a really big computational challenge. We'll have some idea, and we'll need a data set at some random geographic level for some random time period, and we can do it.
So going into the weeds a little bit, why did you create a broadband connectivity index, Scott? You said there are error rates in data sets. How do you remedy that? And I think the answer was you created an index.
Yeah, indices are always popular. People love to rank things. When done badly, they can, of course, be kind of useless because often people will just take a bunch of criteria and add them up and say that's the ranking. And, that's gives us all kinds of implicit weights in it, or you're implicitly deciding that everything has the same weight. But the good part about an index is that it combines lots of information. And that's what we want to do. So the idea behind this connectivity index was to find many different measures of connectivity and combine them in a way that allows, using what's called the principal components analysis, to put them together into to sort of get some kind of overall picture of connectivity at whatever level, whatever geographic level you're talking about. And so what that really does is allows you to find areas that require more focus. And then you can break the index apart to see, what are the issues in different areas, because sometimes it's an adoption issue, sometimes it's an availability issue. So that makes this possible. The other thing, which I think is important, is that sometimes what you see is that you're missing data. And that's important too, because states, some are engaged in their own mapping efforts, which can be useful. But if you can identify smaller areas where you need more intensive data collection, that can save a lot of money. So there are all kinds of uses for it. And this is just one approach to getting new information by combining existing data sets.
Why doesn't the data come in the form of counties and states like it would need to be read? Like, are we ahead of the curve here? Are states
so I think there's a couple of reasons for that. I think the main one is simply that you have to make choices about how to aggregate the data. And I think it's better that the FCC isn't deciding, okay, here's how we're going to aggregate the data and distribute it for higher levels. We're just going to distribute the base level data.
I think the FCC actually gets kind of a bad rap for the 477 data. When you're talking about identifying unserved areas, specific unserved areas, it's not quite the right thing, although it could be a starting point. But they show data at the census block level, and there are 11 million census blocks in the US. That's pretty granular, and those can aggregate up to almost any other geographic type that you're interested in.
Do you think the new data, the broadband fabric with higher resolution, will be better to use, easier, harder? Like, I know Nathaniel has some speculation. How are we going to use that data in our map, the new data that's coming?
So I am extremely excited to look at that data whenever it comes out, because I think it's just going to be interesting to see how they release it and deal with it. The worry I have is that the 477 data is already, 2 gigabytes in size just for the current data. When you are covering smaller and smaller geographic areas, like each individual parcel of land or whatever the thing is going to be, you're going to have much more discrete data, which is going to massively inflate the size of the data set, which makes it harder than to aggregate into larger areas to do useful analysis with. Now, I think once we have the data, it's going to take a little bit of finagling to figure out how to exactly use it, but I do think we'll be able to get good information out of it. But I'm nervous about the complexity of doing GIS with the data and analysis and combining it into higher level usable information.
I'm with Nathaniel on this. On the one hand, super excited for this data to come out because, well, we want to use it. We want to incorporate it into our map. And, every new data set we add to it makes it that much more useful. But it is a little bit worrisome because, like Nathaniel said, it's going to be enormous and everybody may have different uses for it, which means you're going to need to work with some version of the raw data, which it's going to take some skill. But also, I am a little concerned that people have an idea that this data will finally be the broadband map. It'll tell us exactly where broadband is and where it isn't, and that's the end all and be all. Of course, that's not true for a lot of reasons. One is that every data set has error intrinsic into data sets and maps. So there will still be errors in the data. And that will not mean that the FCC did a bad job, but we need to be ready for that and think about how to deal with it. And the other is, of course, that it will need to be updated frequently. And that will presumably also be costly. The other thing is that kind of data will be useful, hopefully, for identifying the unserved areas. But I have a feeling that in most analyses, people will end up aggregating it up to higher levels anyway. And so we're going to find out that, we've done all this work and we end up still doing analyses at the county level or, census tract level. And of course, there's nothing wrong with that. But I'm not sure that people will use the data. The data will be useful in as many ways as people expect.
Yeah,
so split minds. I'm really excited and a little skeptical. But Sarah, one thing we haven't mentioned, one of the origins for this is something that you did as a graduate student. So with Fiscally, why don't you talk about that? Because that was sort of a primordial version of this, right?
Oh, yeah, right. Well, I did want to talk about the Universal Service Fund funding and just the need to track where the money has gone. And so my project as a grad student was to create a website that made it easy to see where E-rate money was going. So USAC puts out these open data sets that are historical, that are really granular. You can see how much E-rate money is going to every school and what equipment they're buying, what speed internet they are getting. And so I wanted to provide some transparency to that great data. And that raises other points too, that, well, we should be learning from all the billions of dollars that are being spent already and improving on the Universal Service Fund. So that's part of why data and data practices and like web development is so important, because if you can match up where the subsidies are going by school with the speeds and where areas are unserved, then we can actually figure out where money should be going to fix the problem faster, to narrow the digital divide faster. So the motivation behind all this is to get the money to where it needs to be. And the missing link is really having better data matching and mapping and the analysis behind it. And that brings us to other like applications for why like a broadband map that includes analysis is so important, because you can answer policy questions like, how effective are the affordability programs? Where's the EBB money going? Is it helping connect people? There are other policy questions that we've been investigating with our mapping tool, state-specific questions. Where is funding going in Florida? So I'll just have a little soapbox here too. I think, we can tweak the way USAC it distributes their open data. It could be a little bit easier for researchers to use. The USAC data sets could have FRN numbers in the data sets. It can have the NCES school codes in them, but they don't currently include those.
And if you know what that means, you know way too much about E-rate.
Yeah. So for somebody who's very interested in the digital divide and like seeing broadband money be spent well, there are a lot of improvements that can be made with the government data. So we're just part of that effort, and that's why we're doing all this coding and and research on broadband data.
But Sarah, also, I think you're making two important points, though, also implicitly. One is that this kind of tool is an input. We don't have a national strategy of building a broadband map instead of tools, and then we're done. We don't actually care about that. We care about it to the extent that it's useful. And so the second is that it helps us answer important questions. And when you talk about the USAC data, with the data that USAC provides, you can combine it with other data to see how effective it's been. And that's what we really want to do. And those suggestions for USAC are really important. But though we do want to make sure USAC knows that we think their data sets are great. And so keep them coming.
So maybe to wrap up, what you think we'll be doing next with our map? What's coming down the pike?
So I have a bunch of features that are just improvements to the actual user experience. I want to make it so that people can save the state of the map so that they can share their exact setup of how, what variables they have set up on the map and the scatter plot and everything. I would like to at some point put more time into working on making it so that you run multivariate regressions with multiple variables. We want to at some point make it easier for people to download the data that we've assembled so that they can use it more directly if they want to. We're waiting for the new FCC data to come out. We're excited to work with that.
Well, there's so much we can do with it behind the scenes that's not available on the front end yet. And so many features that are in progress, but we don't quite have we don't have the financial resources to fully build them out yet. So it's kind of the opposite of vaporware. We've got tons of great analytical tools that we can't show anybody. So there's a whole lot more back there that we hope to bring out.
Thank you, Nathaniel and Scott, for talking about our broadband map project at the Technology Policy Institute. And we'll continue to be working on these broadband tools to help all the folks who are going to be working on state broadband plans and interpreting the broadband fabric data sets that are coming.
And if you want to hear more, reach out to us. Send an email to info@techpolicyinstitute.org.
And look at the map at tpibroadband.com.
Yes, or your own state at tpibroadband.com/state. And pick your state.
You can also visit broadband.tools for our white paper.
Yeah, we have a lot of things.